2010, number 5. All right, I'm going to try to give you a couple of hints to see if I can get you started on this. So for part A, we have to find g of 3 and g of negative 2. What I'm going to show you is the fundamental theorem of calculus, which says, this is the first fundamental theorem of calculus, f prime of x dx from A to B. If I integrate f prime, I get f. Upper limit minus lower limit. So what I want you to think about as you're finding g of 3 and g of negative 2, you're being asked to find g of 3. Let's start with that one. You have information on g prime. You have to integrate. You want to think about what limits can you put in for A and B. Now again, think about g of 3 first. Can you put that in as one of your limits? And you only want, you want to use one of the limits should be what you're looking for. The other limit should be something that you have information on. So you want to be able to substitute in. So one of your limits should be a 3 because that's what you're looking for. But think about what other given information do you have that you could substitute in. Then I want you to think about, after you set that up, how do you find the integral of f prime, or in your specific case, of g prime? That just means the area under the curve. So you should be able to do that right on your graph. Just using your graph, you should be able to find an answer for the area under the curve, depending on what you use for your limits. And then that should equal f of b minus f of a. The area under the curve should be a number equal to, one of these should be an actual number that was given to you. One of them should be what you are looking for. So see if you can use that, and you have to set this up separately. Do g of 3, you have to go through the process and do that first, and then you have to do the same process for g of negative 2. So think about how you might be able to do that. Okay? Now, for part B on this question, I want you to go right back to your justifications. Find the x-coordinate of each point of inflection on the graph on the interval and explain. Think about your justification. When does g have an inflection point? So write out your justification. Then think about what graph do you have in front of you and what are you trying to find? Okay? So that's going to be the key there. Write the justification and go from there. This is just one of those graphing questions that we've done. Okay? Part C gets a little tricky. H is defined as that function there. Find the x-coordinate of each critical point of h. If you recall, a critical point means that the derivative is 0 or dne. So keep that in mind. You want to find where the derivative is 0 or dne in the interval. And we have to classify each as a min, max, or neither. So that's what we have to look at here, okay? So this one's a little tricky. I'm going to try to get you started on this. I want to know h of x was given to me as g of x minus 1/2 x squared. If I want to find the critical points, then I want to know when the derivative is 0 or dne. So h prime is, the derivative of g is g prime minus, when I take the derivative here, I just get x. So that's my derivative. So I want to know, when does g prime of x minus x equal 0? Okay? This is what I'm looking for. Because I'm told at the beginning of this problem that the function is differentiable, then I don't have to worry about a d and e because it's differentiable, so the derivative is going to exist. So I want to know, when does g prime equal 0? So that's what I'm looking for here. So now, if I look at this, remember, g prime is the graph sitting in front of me. So I want to know, when does g prime of x equal x? The best way for me to visualize this, and I'll see if this helps you guys, see if this makes sense to you. I want to know when g prime, which is the graph sitting in front of me, is equal to x. Think about this as a y1 and a y2. y1 is graphed for me, y2 is x. That's my second function, and I want to know, when are they equal? So when do they intersect? So that line, y equals x, that's just your diagonal line going right through your graph. So from that, you can tell you should have 2 points where they intersect. So what you need to do, if you're picturing that dotted line through here, we can automatically see that this is one of our points, 3, 3. The other point is somewhere on this curve, and I think that line visually. So now I need to find out, when does x, which is essentially my answer here, equal the equation of this curve right here? That's a semicircle. So you need to think back to the equation of your semicircle. If you recall, x squared plus y squared equals r squared. My circle is centered at the origin, and the radius is 2. X squared plus y squared equals 2 squared, which is 4. So y is equal to the positive square root of 4 minus x squared. That right there, if you're looking at it, that right there is the equation of the positive part of my circle. That equation is g prime. That is g prime for that part of the graph. That piece of this graph is that equation. So I want to know, when does the square root of 4 minus x squared equal x? That's what I'm looking for here. Square both sides. 4 is equal to 2x squared, 2 is equal to x squared, and x is equal to the square root of 2. That's that other point. So you've got the square root of 2, and you've got 3. Those are your 2, if you're looking at it, those are your 2 critical points that you're going to deal with. And then you have to decide, if I go back to the question here, if that's a relative min, max, or neither, and explain. Again, you're going to use your justifications. Now, hopefully that helps you get started on this. Just so you can check some of your work here. Here are the answers to Part A. Part A is right here. Part B, oh, excuse me, that's still Part A. This is Part A, G of 3, and then G of negative 2. And then you can see you have points of inflection here with your justification. So see if that helps you get started there. Hopefully, you can take it from there. All right. Here are the answers to Part C. You can see my analysis for the two critical points that we had, and whether they were a max or a min or neither. So that's my justification, and then my scrap work to figure out how I got my positive and negative signs.